Okay, today I'm going to talk to you about limiting reactants. We're going to see how to work out the mass of a product based upon information about the mass of a reactant. In a chemical reaction, a reaction stops when all of the reactants are used up. So therefore the mass of the product is limited by the amount of reactant that we start off with. Now, to work this out, we need to know this equation triangle here. N equals M over Mr. M stands for the mass. Whenever we're doing these types of calculations, the mass is given in grams. N is the number of moles. So kind of the number of particles involved in the reaction. And Mr means relative formula mass. Now this could also be relative atomic mass. It just depends on whether we're talking about an element or a compound. So let's have a look at this question. We've got to calculate the amount of aluminium oxide which is being formed. So the first thing that we need to do is we need to write a simple equation, balanced symbol equation for this reaction. So we've got aluminium is burned in air, so we have aluminium. If we have burning happening, it must be reacting with oxygen in order to form aluminium oxide. Okay, in order to deduce ionic formula, you can watch another video. And also to balance equations, you can watch another video as well. But I'm just going to write this nice and quickly just in front of here. So what I've got is a balanced symbol equation. So what I'm trying to figure out is the mass of this which is being produced. If I start off with a limiting reactant, which is 135 grams of this, that's going to limit the amount of this I can make. So the first thing I need to do is I need to find the relative formula mass of these different things here, okay? So if I just get my periodic table, I can find out the relative atomic mass of aluminium is 27. Please note at the moment, I'm just going to ignore the numbers in front. You'll see why in a minute. And for aluminium oxide, I've got 2 aluminium atoms and 3 oxygen atoms. So I'm going to have 2 times 27 plus, that's the mass of oxygen, and I've got 3 of them, so it's going to be 3 times 16. So I'm just going to use my calculator to find out what that is. So 2 times 27 plus 3 times 16, the answer is 102. So the relative formula mass of that one is 102. Now, at the moment, I can't find the mass of this because I need to find the mass of this. I need information about the relative formula mass and the number of moles. However, I do know the mass of this because it says I've got 135 grams of aluminium. So that's my mass of aluminium right there. So to find the number of moles of aluminium, what I need to do is so if I'm finding the number of moles, I need to do the mass divided by the relative formula mass. So I'm going to do the mass. To find the number of moles, I need to do the mass, which is 135, divided by the relative formula mass, which is 27. So the number of moles is, I'm just going to do that on my calculator, 135 divided by 27, which is 5. So I've got 5 moles of this reacting. Now the next bit's really clever. What I need to do is I need to look at something called the molar ratio. Now this is the point where I look at the numbers in front of the different substances. I have a 4 in front of here and a 2 in front of here. Now what that means is for every 4 aluminium atoms, I'm forming 2 molecules of aluminium oxide. So to express that as a ratio, I could show that as a 4:2 ratio, because 4:2. Now an easier, more simplified way of showing that is it's a 2:1 ratio. Now, what we need to do next is this. If it's a 2:1 ratio, that means for every 2 atoms of this, we make 1 molecule of that. So if we have 5 molecules of this, we need to find out half of that because it's a 2:1 ratio. So for every 5 of this, we find, so 5 divided by 2, which is 2.5 moles. So for every 5 moles of aluminium reacting, we produce 2.5 moles of aluminium oxide. So we can now go ahead, now we have information about the number of moles and we have information about the relative formula mass, we can now find our mass. So to find the mass of this, all that we need to do is cover up the M, and we're left with the number of moles times the relative formula mass. So my number of moles here is 2.5, and the relative formula mass of this is 102. So therefore my calculation is just going to be that there. So the mass of this, let's quickly use my calculator again, is 2.5 multiplied by 102. So the answer is 255 grams. So what I've done there is I've found, based on, this was my limiting reactant here because I had a finite amount of it. It reacted with oxygen in the air. So for every 135 grams of aluminium that reacts, I'm going to produce 255 grams of aluminium oxide. Thank you.